Thank you very much for excellent presentations. We have several questions for the from the audience. One second. Question was, you spoke about an update of the VDT model. When was that? And do you think that there are also developments on new models on mold grow?
Well, the update on the VTT model, so the Finnish mold growth model, I actually put the link in the slides for everyone to find. If you look at the references, it seems to be something that they've built on throughout the years. So I don't think there's like one date on the update, let's say. But they actually published an Excel file, which is the one I based my implementation in Modelica on, with a lot of the details actually. So they're quite open source on it. But I don't have an exact date on when it was done. And interesting new models. To be honest, I was looking for something that worked. This worked, and I didn't really look into all possible other mold growth models. So I don't have a fixed answer for that as well.
Okay, thanks. That's a clear answer. And next question: do you have the values, possible number of spore counts that you use for the mold index?
I don't have them, and especially not by heart. Again, it was more about implementing a methodology within our framework and coupling the two aspects together. I'm not a mold expert myself, so I'm not sure. But if you look in the table I presented, you'll see that it's mostly based on mold index 2. Then they looked at the microscope and kind of said, well, if more than 10% is covered, then it's mold index 2, and I think it goes to 3 if more than 50% is covered. I'm just checking it. So it's more on a very pragmatic level. I think it seems to be very empirical that they did tests. They say, well, in these conditions, you get into this mold growth, you get this mold growth index, and try to, and based on that, I guess, derive the classifications.
Okay, thank you. You know, in AIVC, we were really looking into DALIs, and also if you look to the new, how they called, the choices member states have to make about indoor environmental quality. They are also looking at DALIs. Do you think it's possible to translate mold index to DALIs? And it was also a related question. Multi area size and asthma symptoms score and control in adults, the constant cohorts. I don't know if you are familiar with that.
I'm very familiar with DALIs, not with DALIs for mold specifically, but I think in terms of the modeling, a bioscience engineer should figure out if there is a correlation, I guess, between mold spore source rate, let's say, of mold spores emitted to the air and the mold index. And once you have a source rate of mold spores, for instance, based on the index, it's a matter of estimating, well, how much area you have at the low thermal bridge levels in the space, figuring out, which index do you have, which source strength of mold spores do you need to attach to that, and then I guess you can, assuming that everything mixes in the space, get an exposure profile of people to those mold spores. So I think there's it's not a direct correlation with this, but I think it's only a small step to add it as a contaminant in the air model, of course.
Yeah, and we need epidemiological data that we can link the.
And then we need, of course, data to the DALIs. Yeah, definitely.
Yeah, you see, you reduce and increase the ventilation rate. Does outside air supply in most cases reduce the risk of mold grow? Because you change the amount of air changes.
In cases that we tested till now, it did.
Okay.
But there is maybe one, yeah, for our, in the cases that we tested, we did. But like I said, it's only the ones I showed you in the sense that we fixed temperature profiles. It's for sort of first step. But I guess it really depends on the climate you have.
Sure.
And also if you're cooling or not. Because if at some point you're actively cooling in your buildings because of the climate, and if it's necessary, you're also dehumidifying typically. So in that case, it could be that it's actually not better to ventilate more. But I guess that's just more of a result of the relative humidity and temperatures that you feed into the mold growth model. So moving this methodology to a climate where that's relevant, I think would still make sense.
Okay, thank you. And next question, is the impact of the reusing mold growth better with natural ventilation only, mechanical ventilation only, or mixed mode ventilation? Oh, I think your slide 19 answered that. Okay.
Wait, let me check. I do not know the slide numbers by heart. So what's the question? Just checking. Yeah, if you mean natural ventilation only, like only the air changes you have by. So,
so
in the model, I always assume that the infiltration rate is there, of course, but it needs to be at a certain level. It needs to be at a level higher than you would want it to be for energy efficiency reasons, I think, to get to the right air changes. So either you need to be very, very conscious about opening windows, but even that's, of course, not very energy efficient if you have to do it in the winter. So I think, indeed, mechanical ventilation to a certain level combined with acting on the thermal bridges is I think, the approach that seems to be the advice based on what we see now.
Okay, thank you.
But I don't have a real answer on energy efficiency yet, but that's something that we will investigate in the project, of course.
Thank you. Is the formula you showed effectively the equilibrium relative humidity, so, ERH, and is it the surface relative humidity at the surface of interest or surface water activity?
So the model, the Finnish mold growth model, takes relative humidity at the surface and temperature at the surface as input. So in the model, what I did is I coupled a very small EMPD model. Well, small in the sense it's an EMPD model, but I assumed that it's only a small surface area of the whole space. And then in the top layer, which is like so it's at the first micrometers, let's say, you get like a good estimate of the relative humidity levels in the material, and that went as input to the Finnish mold growth model together with the surface temperature of that layer. So I guess that, and indeed the formula I showed is effectively trying to get the vapor pressure beneath the relative humidity of 80%, but calculated at surface temperatures of the thermal bridge. Yes.
Okay, thank you. Excellent presentation. Apology if this is slightly slightly tangential to what your model does, but is there any way that anyone has thoughts of including the role of daylighting in the growth of mold?
Again, I applied the model I found in literature on our model, so I have no idea if there is in any way a relation. Well, I don't know if there is a relation, and if there is, it's not included in the model at this point, at least.
Okay, clear. But maybe how they call it? It can influence the surface temperature, direct sunlight, or I guess. How do you achieve the art changes that you suggest when in homes and some workplace there is no fresh air intake? What is the natural air change without mechanical ventilation system?
So in the model, so the basic situation, we assumed the original facade. It's from the turn of the century. So it's well, those are very leaky windows. So the 0.4 air change is basically what we assume as an air change without mechanical ventilation. But of course, yeah, the first step if you want to increase energy efficiency is to tighten, to add rubbers or maybe change the window if it's allowed, and actually decrease the the infiltration rates. And at that point, dedicated mechanical ventilation systems, ideally a bit controlled for energy efficiency reasons again, yeah, it seems to be the way to go. So yeah, if that's not in place, then it's not an option to install such things, but you do need to air tighten everything. I guess opening the window is kind of your last resort, and then it's a matter of doing that trying to limit the time it needs to be open. And so that means that you want to open it at times that you think vapor pressure indoors would be high. So if you're in a bedroom, that means at least ventilating when you get up, or if it's possible, leave the window open while you sleep. Things like that would help for the mold growth or against it.
Yeah, and I guess also if you limit the opening, you also can control the ventilation flow during winter. Electric dehumidifier can have a coefficient of performance over 1, as they recover the latent heat of vaporization for water vapor. Should we consider fixed dehumidifiers, maybe with some ventilation with heat reclaim?
So a fixed dehumidifier, like adding it in each space, seems for me, maybe as a designer, seems to be more of a of a, what do you call it, noodoplossing solution if there is a problem, of course, and you notice there is mold and there is no way. Yeah, you can of course start dehumidifying, but it's energy you need. And I guess if you're thinking about redesigning and what we are doing in the project, yeah, I don't think that's that's a solution we should propose for some pragmatic reasons as well. But yeah, it seems that it's quite easy to, at least for the case I showed, to impact the thermal bridge a little bit, add the mechanical ventilation, not specifically but just the one that you need for general well-being indoors, CO2 and stuff like that. That already seems to solve a lot of the issues. So I don't think we need to take a step to active dehumidification unless there's an issue. Yeah.
Yeah, I can imagine that in certain climates you have to do it. So in certain parts of the United States, but in our more Western climates, maybe we can do without. Considering climate change is on the way that we start having hotter and more humid summers, have you done some modeling on different outside temperatures with EMPD model tool? Do you recommend what EMPD modeling tool do you recommend the most?
We didn't do future climate scenarios yet. Of course, it's just an input to the model, so it's something that's possible with the tool, but we didn't do it yet. Which EMPD model do we recommend the most? So the ones that we use is a very white box approach. So it's based on research that are at our group. Which is really an EMPD model of a specific material, which I think it's interesting. So well, looking at the thermal bridge, and so most of our spaces are plastered. So the EMPD model we use is based on the moisture transport characteristics, of vapor transport characteristics of plaster, and then you can derive, well, how the model should behave based on, for example, 2 states. So in this, which is a typical assumption at 24 and a year frequencies. I don't know if there's an actual name for the MPD I'm using. I always call it the Bakker because that's the name of the colleague here that developed it. But feel free to contact me if you have questions on it or other suggestions maybe.
Thank you. Many basement walls are cold even in hot and rainy summers. Summer condensation is an issue we often meet. And then that's how do you call it? A remark, which is also raises some questions. Increased ventilation is not a good idea in basements of older houses. Now, what is your idea about that?
But I don't have a fixed opinion on this yet. It's also something that we will investigate in the project, more specifically in the Trondheim region is also included in the project, and they specifically will look at these kinds of issues because of the wooden construction, which makes it even more prone to such problems. So I'm not sure I don't have an answer yet on what the ways to approach this, but it's interesting to mention because it's something we could look at in our simulations as well to see if we don't end up with moldy cellars and basements.
And we've only 1 minute left for the final question. In the Netherlands, we have like a minimum ventilation rate to just get rid of the moisture which comes from the ground floor, but that is one approach. The last comment is proposed insulation solution is likely to result in failure of the roof of the bay window due to interstitial condensation.
Okay, we will have a look at it, I guess.
Okay.
So the comment is that, just to be clear, that the solution that we propose will be an issue. I don't think it will, because we have one layer of OSB which will act as a vapor retarder in this case.
Okay.